let's apply the fundamental theorem of calculus to some explicit functions here and show that the antiderivative is going to get it, or just use the antiderivative to find or evaluate the integral. Anyway, so in the first case we have x squared minus 3 dx from 1 to 2. So what we're going to do here is we're going to apply some of the properties of definite integrals. We're going to say this is from 1 to 2 of x squared dx minus 1 to 2, 3 dx. So in that particular case, we're just going to split up this into two separate integrals. Now we don't have to do that, but this is probably a good way to get used to doing this. So then the antiderivative of x squared, we add 1 to the power and then divide by that power. So it becomes 1/3 x cubed from 1 to 2. And then we subtract, well, the antiderivative of a constant is just that constant times x, so it's 3x from 1 to 2, which is then, so I'm going to say that's 1/3 times 2 squared minus 1/3 times 1 squared minus 3 times 2 minus 3 times 1. That's a lot of writing there, but let's bring that all the way over here. So that 2 squared is 4. So I have 4/3 minus 1/3, all minus 6 minus 3. So that's 1 minus 3 which gets me -2. So the value of this integral is -2. Notice that it's not a positive number, so thinking about it in terms of area is probably a bit naive. Now, for this one, we have 3 square root of x from 1 to 4. So what we want to do here is use the properties of integrals. We can bring the constant out. And then instead of writing it as square root of x, we'll write it as x to the 1/2. So we'll say 3 x to the 1/2 dx from integral from 1 to 4. And then we can use the power rule for antiderivatives to say that's 3. So I'm going to use a double bracket here. Sometimes you'll see a double bracket when you have a constant on the outside. So we add 1 to the power, 3/2. Now we divide by that new power, 3/2, from 1 to 4. So then we can either, we can evaluate this, or we can pull out that. Now remember that 3/2 here flips and becomes 2/3. Whoops, 3. 1 to 4. Now we can pull that 2/3 out. We can say that that's 2 x to the 3/2 from 1 to 4. At which point we can then evaluate this. We can say that's 2 times 4 to the 3/2 minus 1 to the 3/2. So 4 to the 3/2, what we want to do is we'll take 4 to the 1/2 power. Well, let me just write it out. So that's 4 to the 1/2 to the 3rd. And of course 1 to any power is just 1. So 4 to the 1/2, well that's 2. And 2 to the 3 is 8. So our answer is 14. And finally, we have the integral from 0 to pi over 4 of secant squared x dx. Now you may not be super familiar with your antiderivatives yet, but the antiderivative of secant squared x is tangent of x. So in this case, we end up with tangent of x from 0 to pi over 4. So we do tangent of pi over 4 minus tangent of 0. And you may not remember your unit circle values very well, but the tangent of pi over 4 is 1. And the tangent of 0 is 0. Giving us a final answer of 1. So this one turned out to be probably one of the cleaner ones, as long as you can remember your unit circle value or unit circle values and general antiderivatives. And we're going to do some more examples just to get more familiar with this.